Okay, everyone, we're going to work on section 12.3 now, which is surface area of pyramids and cones. So let's look at the first definitions. A pyramid is a polyhedron in which the base is a polygon. So one of the polygons that we've studied, rectangles, pentagons, hexagons, etc. And the lateral faces are triangles that have a common vertex. So they'll come up to one point. Not going to draw one, not good at it. We'll see one on the next slide. Then the vertex of your pyramid is that common vertex where those triangular sides meet, the triangular faces. Okay, a regular pyramid has a regular polygon for the base. So regular meaning that all sides are the same measure and all angles are the same measure. And the segment joining the vertex and a center of the base is going to be perpendicular to the base. Okay, so a segment going down the middle would be perpendicular at the base. All right, next vocabulary word is very important. We've got the slant height. And I'm going to put a real red star next to this one. The slant height, and you'll usually see this as a lowercase l in your formulas. If you look at the formula chart, when you get to the EOC star test, it's going to be a lowercase l. That is referring to your slant height. Okay? The height, the slant height, is the height of a lateral face of your triangle, so that one of the sides, which is the triangles on your regular pyramid, that lateral face, they are triangles. And what we're looking at is the height of that triangle. Okay, the lateral area then is the area of the lateral faces only. The lateral faces only, which are the triangles. Okay, so the lateral area is adding up all the triangles. All right. So here's a picture of our pyramid, and we've got a, my base is 16 centimeters. Since I have four sides here, I'm going to say this is a square, but it tells me right here that my base is 16 centimeters. It gives me, okay, y'all can laugh at me now. I better read the problem. I have a regular square pyramid, has a height of 15 centimeters, so that height that they're talking about, let me highlight that in blue here. That height they're talking about is right there. It's perpendicular at that center of the base right there. It's your perpendicular line going to that vertex, that common vertex at the top. And then we have a base edge length, that's why it's a lowercase b. It's an edge length of 16 centimeters. So we're going to find the area of each lateral face. So each lateral means I just want the area of one of those triangles. And so to get the area of one triangle, let's look at this triangle over here. That's the triangle I'm going to look at right now. And I want to find the area of that one triangle. So remember that the area of a triangle is base times height divided by 2. And so the area of each lateral face is going to be, and my area, okay, I'm going to draw in blue again because what I need to do the area of that triangle is going to be the height of that triangle. And so if you look right here on the side, it's this height that goes up the side, that triangle. It's called the slant height. There it is, L, your slant height. So how do I find that slant height? Well, here's the way we find it. We're going to make a right triangle out of the slant height, that height of the pyramid itself that goes from the center of the base up to the vertex, and then from the center of the base over to the edge of the pyramid, over to the edge of that square. And so I get that right triangle. Let me redraw that right triangle out here for you. Okay, where the bottom side of that triangle is half of your base, because look at, I'm going from the center of the base Let's do that in red. Here's the center of the base, and it goes to the edge. And so that center of the base to the edge is going to be half, which is going to be 8. And then I have the height of the figure itself, of the pyramid itself, which is 15. And so to get that L, that slant height, you're always going to be doing Pythagorean theorem. So I'm going to get 15 squared plus 8 squared equals my slant height squared. And when I do 15 squared plus 8 squared, I'm going to get 289 equals my length, or my slant height squared. So remember, lowercase l, slant height. L is 17. When I take the square root, I'm going to get 17. So there is that slant height. So now I can go back to the area of one lateral face. Area is base, and the base of that lateral face, that triangle, is 16. And times the height, which is going to be, for this, in this case, because it's one of those triangles, it's going to be one base times the slant height divided by 2. And so 16 times the slant height, which we found to be 17, divided by 2, gives me an area of one face of 136, and that's in centimeters squared. So that's one triangle. Okay, so that was just one face, one of those triangles. If I wanted the lateral area, it would be all 4 of those triangles, and so I would do the perimeter. Now let's get to that in a minute. The surface area, so the whole surface area of a regular pyramid, here's the formula for it. Make sure you write it down. The surface area of a regular pyramid equals capital B plus 1/2 perimeter times slant height. 1/2 perimeter times slant height, and one base. I only have one base in a pyramid, right? And so I'm going to add one base, so your capital B is the area of the base. Your capital P is perimeter. And slant height, that's your L. That lowercase l is slant height. Okay, slant height. So let's find the surface area of a pyramid. We're going to find the surface area, and when it says surface area, they want the total. We want total surface area of the hexagonal pyramid. So we name it by the base. It's a hexagon on the base. So remember that the surface area formula is the B, capital B, base plus 1/2 the perimeter times the slant height. So S is going to be the area of the base, and let's look at how we get the area of the base. Okay, the area of the base, I'm going to do that over here. The base is going to be, it's a hexagon, so I'm going to have to use my apothem times perimeter, and the apothem is 5 square roots of 3. That's given to me right here in the triangle on the base. 5 square roots of 3 times perimeter. I've got 10 for one side, and I have 6 sides to that base, so that's going to be 60. 5 square roots of 3 times 60 divided by 2, and that's going to give me the area of the base, which is going to be 150 square roots of 3. Okay, so let's put that area of the base in, 150 square roots of 3. 150 square roots of 3 plus 1/2 the perimeter, which we already said was 60, times the slant height. Now let me go to the blue, and this will be the slant height right there is the height of one side, one of those triangles on the side. And so they give me that, which is 14. And so I'm going to get 150 square roots of 3, and I would recommend doing each side. You've got 150 square roots of 3 on the left side of your plus sign. So now let's go do the multiplication here, 60 times 14, and divide by 2, and I'm going to get 420 on the right-hand side. Now, can I add these two together? No. This is an exact answer right here. If we want exact, if it says exact in your answer, in your problem, then that's what I want, exact answer, with the square root of 3 in it. However, if it doesn't specify, then we can say, okay, my surface area equals approximately 679.81 feet squared. So I would go ahead and plug that in. 150 times the square root of 3, and then plus 420, and that's your total. Okay, now let's look at a cone. And a cone has pretty much the same formulas for it, but let's define what a cone is first. Okay, so I have written in the definitions, but let me go over them with you. The cone has a circular base and a vertex that's not in the same plane as the base. If I had the vertex in the same plane, it would just be a circle. It would be two-dimensional. So that vertex point is what brings it up to 3D. A right cone is where I have a segment that joins the vertex and the center of the base down here. So it joins the vertex and the center of the base right there, and it's perpendicular at the base. Perpendicular line at the base. So I get another 90-degree angle. So I think you can probably see where we're going with the cone. If I take half, which is half of that diameter is the radius, and then the height of the cone goes from the center of the base to the vertex, and then again, this height out here is called the slant height, L. It's listed right there. So again, I'm going to get those right triangles that I'm going to have to solve in order to solve problems using a cone. So let's look at the surface area of a right cone formula. The surface area is the area of one base plus 1/2 the circumference, because it's a circle, it's circumference, not perimeter. Distance around it is circumference, times L, which is the slant height. So let's look into this formula just a little bit further, though. We already know what B is, don't we? Surface area. If I want the area of that base is a circle. So I'm going to get pi r squared, area of the base. Then I'm going to have 1/2 the circumference. Again, with this, since this is a circle, instead of perimeter, it's circumference. So it's 2 pi r times the slant height, L. Now, look what happens here. When I'm over here on the right side of my plus sign, I've got a 1/2 times a 2. Well, guess what's going to happen to the 1/2 times a 2? This would be 2 over 1, right? Those are going to cancel. It gives me 1. So my surface area for a cone is going to be pi r squared plus pi r L. Okay, so that's going to be our surface area for a cone. So let's look at this cone shown. What is the approximate surface area of that cone? Here's my surface area equals pi. My r is 5 squared plus pi. R is 5 again. Now we need the slant height. But look what I have. I have the height of the cone here, which is 6. I don't know the slant height with it, which is that one. And then here is that right triangle then. So I can do 6 squared plus 5 squared is going to equal that slant height squared. And when I plug that all in my calculator, 6 squared plus 5 squared, and then I'm going to take the square root of it, my L is going to be 7.81. And so that's what we're going to put here, 7.81. All right? So pi 5 squared, that's 25 pi, plus 5 times 7.81 pi. And you know what? We're just going to plug that in, because if you look over here at my answers, they're all in decimals. So 5 times 7.81, go ahead and plug in your pi now, and my surface area is about 201.2. Okay, let's look at one more. Traffic cone can be approximated by this right cone that has a radius of 5.7. So let's say this has a radius of 5.7 inches and a height of 18 inches. Okay? We're going to find the approximate lateral area of the traffic cone. So if we go back and look at the surface area, the total surface area, where we do the base plus 1/2 circumference times the L, well, a lateral area is where I want this part, let me put it in red, this part right here. That's just the surface area around the cone without a base. So if we want lateral area, we want everything but the bases. No bases. No bases in lateral area. So let's look at, to find the slant height again. There's the slant height right there. That's my L. And so I can do, this is my right triangle here. So your L, your slant height, is always going to be the hypotenuse. So I've got 18 squared plus 5.7 squared is going to equal my L squared. So plug that into your calculator. I'm going to get L is 18.9. Okay. So now we're going to find the slant height. So I'm going to go back over here and we'll find the slant height. Wait, approximate lateral area. Sorry. We're finding the approximate lateral area now. So we could say lateral area is going to, now let's not use the lowercase l. Let's just call that lateral. Lateral area is going to be 1/2 the circumference, and remember your circumference. Well, now if we look at the formula again, 1/2 circumference is 2 pi r times L. So again, that 1/2 and the 2 is going to cancel. So I don't need the 1/2. I might just have to start this whole one over. Pi r L. So the 1/2 and the 2 cancel, and I just want pi r L. So pi times the radius, 5.7, times the slant height of 18.9, and then my lateral area is going to be, okay, since we have decimals, we can keep using decimals. I'm going to plug that all in and get 338.4, and do we have inches? And it's an area, inches squared. Area is a unit squared. There is the lateral area. All right, so I think you're ready to go with the pyramids and cones.